Okay, so number 7. Find the common ratio of 405 to 135. So what is 135 divided by 405? Okay? And you should get a crazy looking decimal. It's going to be like 0.33333. So instead of writing that crazy decimal, let's change it to a fraction. So hit Math, Enter, and you should get 1/3. So 135 divided by 405, enter, and then Math, Enter, and you should get 1/3. Same thing for 45 divided by 135. It's going to give us 1/3. So our common ratio is 1/3. Okay. Write a recursive formula for the following sequence: 3, 6, 12, 24, 48, and 96. So we have 3, 6, 12, 24, 48, and 96. So how can we go from 3 to 6? We can multiply by 2, right? So times 2. How can we go from 6 to 12? Times 2. 12 to 24. Oops, not plus 2. Times 2. It'll be the same for all of them. So this is going to be a geometric sequence because we're multiplying by the same common ratio. And each term, so a subscript n, each term can be found by multiplying the previous term, n minus 1, by 2. Right? So a1, a2, a3, a4, and so on. So a2, which is 6, can be found by multiplying the previous term, which is a1, by 2. So 3 times 2 would give us 6. a3 can be found by multiplying a2 by 2. a4 can be found by multiplying a3 by 2. And remember, for a recursive formula, you have to know the previous term. Okay? Let's look at the next example. Write a recursive formula for the following sequence: 81, 108, and 44. 81, 108, 144. So how can we go from 81 to 108? So what is 108 divided by 81? What did you get? You're probably going to get a crazy decimal, so change it to a fraction. It's 4/3. So we're going to multiply by 4/3. 144 divided by 108 is 4/3 as well. So our common ratio is 4/3. So each term, a subscript n, can be found by multiplying the term before it by 4/3. Now it says use this recursive formula to find the fifth term. So right now we have a1, a2, a3. So we can't go straight to the fifth term because for a recursive formula we have to know the one before it. So we need to know the fourth term. Do we know the fourth term? No, we only know the third term. So let's use that third term to find the fourth term first. So a4 will be the term before it, which is a3, times 4/3. a3 is 144 times 4/3 will give us 192. So the fourth term is 192. Is that what we were looking for? No, we were looking for the fifth term. So in order to find the fifth term, we need to know the fourth term, which we do now. What's the fourth term? Fourth term is 192. So we'll have 192 times 4/3, which gives us 256. So a to the fifth is 256. Like arithmetic sequences, we can write explicit formulas for geometric sequences. So the explicit formula for a geometric sequence is an equals a1 times r to the n minus 1. So we still need to know that first term. We can use it to find any number of the sequence, and we use the common ratio instead of the common difference. So number 10 says, write an equation for the nth term of the geometric sequence 3, 12, 48, and 92. So let's find our ratio first. So the second term divided by the first term. 12 divided by 3 gives us 4. We check all these. 48 divided by 12 gives us 4. And if we did it again, just to be on the safe side, 192 divided by 48 would give us 4. So this is definitely a geometric sequence. Now we're going to find the nth term, so we want to find any term without having to know the one before it. So the formula for explicit formula for geometric sequence is going to be a subscript n equals the first term times our ratio to the power n minus 1. So what's our first term? Our first term is 3. What's our common ratio? 4 to the n minus 1. Now do not multiply the 3 and the 4. You have to keep them separated because of this exponent. So do not multiply the 3 and the 4. Keep them separated. This is our final answer. Okay, write an equation for the nth term of the geometric sequence 4, 6, 9, 13.5. So let's find our common ratio first. So 6, our second term, divided by our first term is going to be 1.5. 9 divided by 6 gives us 1.5. And 13.5 divided by 9 gives us 1.5. So this is a geometric sequence with our common ratio of r. So the explicit formula for a geometric sequence is a to the subscript n equals our first term times our ratio n minus 1. So what's our first term? Our first term is 4. Our common ratio is 1.5 n minus 1. Do not multiply the 4 and the 1.5. You can't because of that exponent. So that's your final answer. Alright, find the 8th term of the geometric sequence for which the first term is -3, the common ratio is -2. So we're looking for a specific term this time. So let's first write our explicit formula. So we know our a1 is what? They tell us a1 is -3. What's our ratio? -2. And we are looking for the 8th term. So this time, instead of leaving it in terms of n, we're going to plug in 8 for n. Now I would advise taking this one step at a time. So we can't multiply the 3 and the -2. We've got to leave them separate. What is 8 minus 1? 7. Now let's see what -2 to the 7th is. Following our order of operations, we have to do exponents first, right? So find -2 to the 7th first. Whoops. What does that give us? should give you negative 128. And what is negative 3 times negative 128? It's positive 384. So our 8th term of that sequence is positive 384. Last problem. Given the sequence defined by the function a subscript n plus 1 equals 3/4 an, with the first term equal 424, write an explicit function rule. Okay, so this one looks crazy, but it's just because they don't give us the sequence directly. They give us the rule for the sequence though. So we're starting at 424. That's our first term. Then they tell us that each following term can be found by multiplying it by 3/4. So what is 424 times 3/4? It's 318. So to go from 424 to 3/4, we multiply. 424 to 318, we multiply by 3/4. Now what's 318 times 3/4? 238.5. And you could go on forever with this. I'm going to stop there. Okay, so now that we have our sequence, it's just like the other problems we did. We just use that sequence to create our explicit function rule, which, since it's a geometric sequence, is a subscript. Why do I keep writing that? A subscript n equals a1 times r to the n minus 1. Okay, so our first term is what? 424 times 3/4 n minus 1. So any term, which is an, is 424 times 3/4 n minus 1. And that's it.